Welcome, everybody. This is the first set of notes for the Integrated Math 3 Plus course. My name is Mr. McGow, so welcome. And for this set of notes, we're really going to go back and kind of review quite a few of the functions that you've worked on in previous classes. So the parent functions are given here at the very outset of the notes. Some of these functions will be things that you maybe have not seen that we'll be exploring this year, but many of these functions will be things that you have seen. So we can see here the linear function, absolute value, quadratic function, cubic function. Those are all functions that you've seen in Math 1 Plus as well as Math 2 Plus, and probably even in your 8th grade math courses for the linear functions. Exponential functions as well, square root functions and cube root functions in the Math 2 Plus course. The newer functions are going to maybe be the logarithmic functions. So that is the inverse function of the exponential, and maybe the rational functions as well. So that is functions where the variable is going to be in the numerator and denominator simultaneously, or definitely at least one variable in the denominator. And so that is going to yield some very interesting results, because if our denominator is equal to 0, what do we do with this division by 0 expression? And so these are going to be undefined values for us. So rational functions, log functions, you don't really need to know much about. Same with trig functions. You've probably worked with sine, cosine, tangent, cosecant, secant, and cotangent with right triangles, but not as functions themselves. So we'll be exploring these functions throughout the course that are starred here. So to kind of start our notes, we're going to go back even further to kind of the starting point of what is a function. So maybe, think for yourself, pause the notes if you need to, and just think about what would a definition of function be for you given the previous courses that you've taken. So a function is going to be a specific relationship between our two variable quantities. So x and y are typically the letters that we use for our variable quantities, but y can also be written as f of x, so you'll note that down here. And we're really going to use this f of x most of the time. It's a little bit more mature notation to be using for functions, and it explicitly tells us what is happening at specific values of x. So like f of 1 tells us what is the y value or the output value when we are at x equals 1. And so while we'll use y interchangeably, f of x is going to be our standard notation that we'll use. So to start then, what is a function? Well, a function is a relation, is what it's typically called, but you can think of it as a relationship between two values. So we have our input, which is x, and our output, which is y, or f of x, such that, if we simply have a relationship between them, that's just what we call a relation. But this relationship is such that every input has exactly one output. And that is the key idea here. So we can have relations where when we plug in x, we get a bunch of different y values. And so that would not be a function. And the reason why a function is important in general is because when we're dealing with real-world phenomena like time, distance, speed, velocity, acceleration, these are going to be functions because at any given point, an object in space is going to have one position at one moment of time, at least for dealing with physics that are at a non-quantum level. So functions are really, really useful for mapping data. And the same is going to be true for economic relationships, population relationships, all sorts of different relationships that we use and model regularly for research, as well as for projecting, future outcomes. So our function is going to be a linear function, a quadratic function, a cubic function, some type of function here. And it's going to be pretty central to our course of being really familiar and comfortable working with functions as well as the vocabulary that comes with them. So the second main idea of a function is the domain and range. So our domain is the set of all inputs, which is all of our x values. So these are all of the x values that make up our function, and our range is the set of all outputs. And those are our y values. And so we typically think of our domain values, our x values, as the independent variable. We get to choose the x value, but that given x value will have a set y value, so y values are typically called the dependent variable. So we would say that y depends on x, or y is a function of x. So let's look at a relation here on the right. We can see the function is given here on the right, and it looks like it's a parabola mixed in with two linear pieces here. So we'll just note that this type of function is called a piecewise function. This is where we take multiple functions and we combine them together to create a singular function with multiple separate expressions or relationships. So our first question is it a function? So if we look at our picture here, we should be able to quickly identify that it is a function. And because it's graphed, we can see by using something called the vertical line test, or VLT. That vertical line test is a quick visual way to determine if your function is itself a function. And that is, if we draw a vertical line, there should be one and only one point that passes through. And this is true for these because we can clearly see that it's quadratic and linear. An example of a non-function would be like a circle, which we'll see on the next page, where we've got two outputs for a given input. And so this is a circle would fail the test using a vertical line. So yes, this is a function by the vertical line test. So again, that's how we can tell if it is or not, quickly visually. And in general, if we're given, f of x equals or y equals some expression, that is going to be how we express a function. If we get something that is not a function, it is typically going to be represented by an equation that has the variables mixed together. So in other words, x and y are mixed together, and there's going to be some constant value typically associated with the equation as well. And so that would be kind of the visual cue that you do not have a function. So x squared plus y squared equals 16 would be the equation of a circle centered at the origin with radius 4. All right, so what is the domain and range of our given function? So this is going to kind of get to what sort of notation are we going to use. I'm not too picky about the type of notation. There's lots of different notation you can use. Inequality notation is probably the one that you've seen the most, but there's also something called interval notation, so you can use either one. So if we're looking at our function on the left, we can see that our smallest x value is -3, our greatest x value is 5, and the function is continuous. It is a connected, it's connected completely through. Doesn't have any breaks or jumps or values that are missing in between. So our domain is going to be every real number between -3 and 5. So how do we write that with our interval or inequality notation? So inequality notation would look like -3 is less than or equal to x, which is less than or equal to 5. Putting the equal to in the inequality because we are closed at the endpoints. And this compound inequality is really going to kind of look the same always, but these may be open if we have discontinuities, which we'll talk about later on in the class. But for now, the functions that you'll see will typically be nice continuous functions that are not disconnected. If we wanted to use interval notation, which I am going to recommend for you because it's just shorter and nicer, is to write it with brackets or parentheses. So we would put -3 comma 5 as like an ordered pair. And then because we have equality at the endpoints, instead of parentheses, we'll put little brackets around it. So that would be how we can represent the set of the domain values. If it was strictly less than, then we would put the same thing as an ordered pair, -3 to 5, but we would put the interval open. So that's the only difference, but it'll look the same otherwise. And we always go least to greatest, so the smallest value will be on the left, the greatest value will be on the right. So again, I don't mind which notation you use. You can kind of decide which one you prefer. So for the range, we're going to do the same thing, only now we're going to look at the y values. So for our function, it's actually pretty easy. This will be a little bit trickier with other functions. So we can see that -2 is our smallest vertical value, and it looks like +1 is our largest vertical value. So our domain then is going to be -2 less than or equal to y, less than or equal to 1. And if we were doing interval notation, it would be -2 to 1 with closed brackets. So again, you can kind of decide which one you want to use. I don't really mind which one you use as long as it's consistent and it's correct. So some secondary questions here that are going to be important to us later on when we're thinking about specific functions is there a minimum or maximum value of our function, and what does that mean? And on what intervals is the function increasing or decreasing? So for our maximum or minimum values, what we're describing there is our maximum or minimum output value. So that's kind of the key, is the output value. So when we want to find our maximum, we are not looking at the x's, we are looking at the y values. So it's pretty easy to see here that our minimum and maximum values are given by the range. So if we know the range, we know the minimum or maximum values. What we should also note, though, is there are some functions where there is no minimum or maximum. So if we think of a linear function, which let's say has positive slope, that function is going to be -infinity to +infinity. So let's note the range of this would be -infinity, +infinity. I'll use interval notation here. We never reach infinity, so we'll use parentheses, not brackets. But this has no min and no max. So there will be functions that do not have these. In our given case above, we can see that we do have those. So the maximum value is not the minimum value. The maximum value is +1 at x equals 3. So x equals 3 is essentially our location, and the y value is our maximum. And then we have a minimum value of -2 at x equals -1. So again, x equals -1 is our location. -2 is the actual value itself. And then finally, increasing and decreasing. So when we're discussing increasing or decreasing, that should be pretty obvious to us, which is increasing means that you have positive slope. So your y values are getting larger as you move from left to right. Decreasing is going to mean that you have a negative slope. So if we look at our function here, let's add in some color maybe. We can see that the function is decreasing from -3 to -1. Then it's increasing after that. We've got this little blip at 1, but it does continue to increase all the way to 3. And then from 3 to 5, we are decreasing again, which means we have 2 intervals where we are decreasing. And it looks like 2 intervals where we're increasing, but those intervals overlap. So let me do that in red. So we've got this parabola region that is increasing, and then the linear portion that is increasing. So for our positive slope, we'll use red, and then our negative slope we have in green. So what we would say then is that we are, increasing on the intervals -1 to 3. And that'll be, we could just write that as an open interval, because at -1, you're technically 0 slope. And at 3, you're technically an undefined slope because you have this sharp end to it. And so we'll leave that open. And so we're increasing on -1 to 3. Because f of x has a positive slope. We're decreasing on the interval -3 to -1, or from 3 to 5. So we would use this kind of U or V to represent or, and so there's 2 intervals, and again, that'll be because f of x has negative slope. All right, so that's the first page of our notes here. I think we'll pause here and we'll make a second part to our video, but really just kind of a reintroduction to functions, looking at graphs of functions, describing domain and range, and then adding in these max, min, and increasing, decreasing intervals. So until next time, take care.